Hello, in this lecture we find out the length of line segment X. In the drawing we have a quarter circle, A or B is a quarter circle. Inside this quarter circle we have a semicircle, and we also know that side AO equals to 10 units in its length, and our mission is to find out the length of this line segment AM is equal to X. So first of all, because of the fact that AOB is a quarter circle, it means that this angle AOB is a right angle. It is equal to 90 degrees in its size. And AO and OB, they are both the radii of this quarter circle, therefore they are equal to each other. But we know that AO equals to 10, therefore OB must be also equal to 10 units in its length. OB equals to 10 units. It is also the radii of this quarter circle. And OB, it is not only the radii of this quarter circle, but it is also the diameter of this semicircle. So now we know that the diameter OB of this semicircle equals to 10 units. Therefore, the radius of this quarter circle must be equal to 10 over 2, that is 5. We define the center of this semicircle as P. So OP is the radius of this quarter circle, therefore it is equal to 5 units in its length. PB is also the radius of this quarter circle, PB is also the radius of this semicircle, therefore it is equal to 5 units. Again, the radius of the quarter circle equals to 5 units, and the radius of the quarter circle equals to 10 units. Okay. In the next step, we will join points P and M together. We will define the point of tendency of tangent AM with this semicircle as Q. And we will join points P and Q together by a straight line. Point P is the center of the circle. Point Q is a point on the, again, point P is the center of the semicircle. Point Q is a point on the semicircle itself. Therefore, PQ is the radius of this semicircle. Therefore, it is equal to 5 units. Okay. In the next step, we have here rule number 1. The radius PQ is drawn to the point of tendency, that is to say, it is drawn to point Q, that is the point of tendency of tangent AM with this semicircle. And whenever you have a radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP. If AM is perpendicular to QP, then this angle will be equal to 90 degrees, and this angle will also equal to 90 degrees according to rule number 1. We will focus on the common external point, point A. Point A is the external point in relation to this semicircle because it is not located on the semicircle nor inside the semicircle. Well, therefore, point A is an external point in relation to this semicircle. From point A, we have two tangents to this semicircle, tangent AO and tangent AQ. And according to rule number 2, that the lengths of two tangents from a common external point to a circle are equal. That is to say, AO equals to AQ. Okay, AO equals to AQ, but AO equals to 10, therefore AQ must be also equal to 10 units in its length. In the next step, we will extend side AM and side OB by a straight line until they touch each other. And we define the touching point of the extended side OB and side AM as point N. By doing this construction, we actually created here the right big triangle, triangle AON. This is the right triangle AON. We will define angle ANO. This angle is theta. And we'll focus on the right big triangle AON. In the right big triangle AON, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is equals to 180 degrees. That is the sum of the angles in any triangle. Likewise, we'll focus on the green right small triangle PQN. In this green right triangle PQN, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. According to the same rule that the sum of the angles in any triangle is equal to 180 degrees. In the next step, we will prove that the right big triangle, triangle AON, is similar to the small green right triangle PQN. So I write it down. The right big triangle AON is similar to the small green right triangle PQN. PQN. Repeat again. We will prove that the right big triangle AON is similar to the small green right triangle PQN. Okay, so why those two right triangles are similar to each other? First of all, those two angles they are both equal to 90 degrees, therefore they are equal to each other. So this is angle in the big right triangle, it is angle AON. And it is equal to this angle in the green small triangle, that is angle PQN. Repeat again. Angle AON in the big right triangle equals to angle PQN in the green small right triangle. They are both equal to 90 degrees, therefore they are equal to each other. Okay. In addition, this is angle theta, that is a common angle, it belongs to both triangles. So angle theta equals to itself. Okay? So if you relate to angle theta as it belongs to the big triangle, it will be angle ANO. and it is equals to itself. So if we relate to angle theta as it belongs to the green triangle, the right triangle, we will define angle theta as angle QNP. Repeat again. This equation means that angle theta equals to itself. We just call to angle theta two different names. It's a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually this is angle OAN in the big triangle. And it is equals to this angle in the small triangle, that's actually angle QPN. Repeat again. Angle OAN in the big right triangle equals to angle QPN in the small green triangle. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually prove that all the three angles in the big right triangle AOM are correspondingly equal to all the three angles in the small right triangle, triangle PQN. Therefore we actually proved that those two right triangles are similar to each other according to angle similarity rule. So I write it down. The big triangle, triangle AON, is similar, this is the sign of similar, to the small green right triangle, triangle PQN. According to angle similarity rule. And from the fact that the two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side AO in the big right triangle over side QP in the small green triangle equals to side AN in the big right triangle over side PN in the small green triangle. Repeat again. We derive that AO times QP equals to AN over PN, and also that side ON in the big right triangle over side QN. Repeat again. From the fact that the two right triangles are similar to each other, we will derive that AO over QP equals to AN over PN equals to ON over QN. AO is 10 over QP is 5, and it is equal to AN. What is the length of AN? In total, AN equals to AQ plus QN. Again, AN equals to AQ plus QN. AQ is 10. So in total, AN equals to 10 plus QN. over Pn. Pn equals to Pb plus Bn. That is to say, Pn equals to Pb, that is 5 plus Bn. So in total, Pn equals to 5 plus Bn. So we found out actually that 10 over 5 equals to 10 plus Qn over 5 plus Bn, and it is also equals to On. What is the length of On? On equals to OP plus BB plus BN. That is to say, ON equals to OP, that is 5, plus BB, that is 5, plus BN. So in total, ON equals to 10 plus BN. ON equals to 10 plus BN. Over Qn. Qn is the missing side, so we leave it as it is. So in conclusion, we found out that 10 over 5 equals to 10 plus Qn over 5 plus Bn, and it is also equals to 10 plus Bn over Qn. 10 over 5 is 2, so 2 equals to 10 plus Qn over 5 plus Bn, and it is also equals to 10 plus Bn over Qn. So 2 equals to this expression, so we create equation number 1 from those two expressions that are equal to each other. So according to equation number 1, 2 equals to 10 plus Qn over 5 plus Bn. Those two expressions are also equal to each other, so we create equation number 2 from those two expressions that are equal to each other. So according to equation number 2, 2 equals to 10 plus Bn over Qn. So actually we created here two equations. We'll multiply equation number 1 by 5 plus Bn, and we'll get that according to equation number 1, two times 5 plus Bn equals to 10 plus Qn. Just multiply the equation by 5 plus Bn in order to eliminate the denominator here. Here we will open the brackets on this side of equation number 1, and we'll get that 2 times 5 is 10 plus 2 times Bn equals to 10 plus Qn. So here we have 10 on both sides of the equation, so 10 will get cancelled. After we cancel 10, we have here Qn that is equals to 2 times Bn. Un equals to 2 times Bn. This is according to equation number 1. In the next step, we will focus on this equation, equation number 2. and we will multiply this equation number 2 by Qn, and we will get that according to equation number 2, 2 times Qn equals to 10 plus Bn. According to equation number 1, Qn equals to 2 times Bn, so we can substitute Qn in this equation number 2, by 2 times Bn. We'll do it now, we get that according to equation number 2, 2 times Qn, and Qn is 2 times Bn. So 2 times Qn according to equation number 2 equals to 10 plus Bn. 2 times 2Bn is 4Bn, so 4Bn equals to 10 plus Bn. Here we subtract from this equation number 2 Bn, and we get that according to equation number 2, 4 times Bn minus Bn is 3 times Bn. That is equal to 10. 3 times Bn equals to 10. We will divide this equation number 2 by 3. And finally we get that according to equation number 2, Bn equals to 10 over 3 units. So we can write down in the original drawing that Bn equals to 10 over 3 units. And we have already found out that according to equation number 1, Qn equals to 2 times Bn. That is to say, Qn equals to 2 times Bn, and Bn is 10 over 3. So in total, Qn equals to 2 times 10 over 3. 2 times 10 is 20, so it is, this expression in total equals to 20 over 3. In conclusion, we found out that Qn equals to 20 over 3 units. Qn equals to 20 over 3 units, so you can write down in the original drawing that this line segment Qn equals to 20 over 3 units. Okay, so in the next step we will complete this quarter circle to a circle. So we completed the quarter circle to a circle, and we'll extend side BO by a straight line until it touches the circle. We define the touching point of the extended side BO with this circle is point C. In the next step, I will present to you But before that, here point O is the center of this circle. Point C is the point on the circle itself, therefore OC is the radius of this circle. The radius of this circle is the same radius as the radius of the quarter circle. We just completed the quarter circle to a circle, so the radius of the quarter circle and the circle must be equal to each other. And we have already found out that the radius of the quarter circle equals to 10, therefore the radius OC of this circle must be also equal to 10 units in its length. So in the next step I will present to you a new rule and we will implement the new rule in our drawing. According to rule number 14, whenever you draw from a common external point, for example point P, two chords to a circle, then the following equation will be true. PA times PB equals to PC times PD. Okay, so in any circle, if we draw two chords A, B and C, D from the common external point P to this circle, so from the common external point P, we drew two chords inside this circle, chord AB and chord CD. So the first chord we draw from point P. So actually we draw line segment PB. By drawing line segment PB, we created chord AB. From the same common external point P, we do here line segment PD. By drawing line segment PD, we created here chord CD. Okay, so in this drawing, so whenever you draw two line segments from a common external point P that cuts the circle at 2 points, like here, line segment PB that we drew cuts the circle points A and B. In this way we created chord AB. Line segment line segment PD that we draw, what we do here, cuts the circle at point C and D. So whenever you draw two line segments that cut the circle at two different points, like in this drawing, the following equation will be true. That PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. Okay? So we can actually implement rule number 14 in our drawing. Why? Because if we focus on the common external point N, from the common external point N, we have line segment NC that cuts the circle at points B and C, and we have also line segment NA that cuts the circle at points M and A. So actually all the requirements of rule number 14 are met, and therefore we can implement here rule number 14. So I write it down. In our original drawing, if you focus at point N, we have two line segments. Line segment NC cuts the circle at points B and C. This way we created here chord BC, and we have another line segment NA from point N that cuts the circle at point M and A. In this way we created chord AM. Therefore all the requirements of rule number 14 are met, and therefore we can implement here rule number 14. According to rule number 14, NB times NC equals to nm times na. Repeat again. Now what you're doing, if you focus at point N, all the requirements of rule number 14 are met. Therefore we can implement rule number 14 in our drawing. According to rule number 14, NB times NC equals to NM times NA. Okay. But before we continue with rule number 14, we will define line segment QM SA line segment QM equals to A according to our definition. So what is the length of line segment MN? From the drawing, it is very easy to see from the drawing that MN equals to QN minus QM. Repeat again, from the drawing it is very easy to see that MN equals to QN minus QM. Repeat again. Line segment MN equals to QM minus QN. Repeat again. Line segment MN equals to QN minus QM. Line segment MN equals to QN minus QM. This is QN minus QM equals to QN. Equals to QN minus QM equals to MN. Again, QN minus QM equals to MN. So MN equals to QN. QN equals to 20 over 3, according to what we already found out, minus QN. QN equals to A, according to our definition. So in total, we actually found out that line segment MN equals to 20 over 3 minus A. MN equals to 20 over 3 minus A. So you can write here that line segment MN equals to 20 over 3 minus A. Okay. Now we return to rule number 14. According to rule number 14, NB times NC equals to NM times NA. So NB, what is the length of NB? NB equals to 10 over 3. Times NC. What is the length of NC? In total, NC equals to CO plus OP plus PB plus BN. So CN in total equals to 10 plus 5 plus 5, that is 20, plus 10 over 3. So in total, CN equals to 20 plus 10 over 3. It is 10 plus 5 plus 5, that is 20, plus 10 over 3. So in total, Cn equals to 20 plus 10 over 3. Cn equals to 20 plus 10 over 3. and it is equal to nm. We just right now found out that nm equals to 20 over 3 minus a times na. What is the length of na? Na equals to aq plus qn. An equals to aq plus qn. aq is 10 and qn is 20 over 3. So in total, an equals to 10 plus 20 over 3. In conclusion, we actually found out that according to rule number 14, 10 over 3 times 20 plus 10 over 3 equals to 20 over 3 minus a times 10 plus 20 over 3. So here we have 10 over 3, and here we have 20 plus 10 over 3. Here we will multiply 20 by 3 and then we will divide it by 3 in order to overcome factor with 10 over 3. So 20 times 3 is 60 and 60 plus 10 is 70. So in total in the numerator we have 70 over 3. And is equals to 20 over 3 minus a. Here we multiply minus a by 3, then we divide it by a in order to have a common factor with 20 over a. So we have in the numerator 20 minus a times 3 is minus 3a over 3 times 10 plus 20 over 3. Here we multiply 10 by 3 and then we divide it by 3 in order to have a common factor with 20 over 3. So 10 times 3 is 30 and 30 plus 20 is 50. So in total in the numerator we have 50 divided by 3. So on both sides of the equation, in the denominator we have 3 times 3. 3 times 3 is 9, so we'll multiply this equation by 9 in order to cancel the denominator on both sides of the equation. And we get that according to this equation, after we cancelled 9 on both sides of the equation, we left only with the numerator here, that is 10 times 70, and it is equals to 20 minus 3a times 50. Repeat again. After we multiplied this equation by 9, we left only with 10 times 70 equals to 20 minus 3a times 50. Here we will divide this equation by 10. And we get that 10 over 10 is 1. So in this side of the equation we left only with 70. That equals to 20 minus 3a times 50, and 50 over 10 is 5. So in total we found out that 70 equals to 20 minus 3a times 5. Here we'll open the brackets on this side of the equation and we will get that 70 equals to 20 times 5 is 100, minus 3a times 5 is minus 15a. So we found out that 70 equals to 100 minus 15a. Here we subtract 70 from this equation and get that 70 minus 70 is 0. 100 minus 70 is 30 minus 15a. So actually found out that 0 equals to 30 minus 15a. Here we'll add 15a to this equation and we'll get that 15a equals to 30. So here we'll divide this equation by 15 and finally we get that a equals to 30 over 15, that is 2. So a equals to 2 units in its length. So here we have a equals to, a is qm, and qm equals to 2 units in its length. Our mission is to find out the length of am, that is x. X is am according to what is given as the question. And what is the length of AM? From the drawing, it is very easy to see that AM equals to AQ plus QM. AQ plus QM is AM. AM equals to AQ plus QM. That is to say, AM equals to AQ, that is 10, plus QM, that is A. So in total, actually found out that X equals to 10 plus A, X equals to AM, and AM equals to 10 plus A. So X equals to 10, and A is 2, so it is 10 plus 2, that is 12. So actually found out that X that equals to AM equals to 12 units in its length. And that is the answer to the question. Repeat again. The length of this line segment AM that is equal to X, it is equal to 12 units. So in the next step, I will summarize the lecture. In this lecture, we found out the length of this line segment AM that is equal to X. We found out the value of X, that is AM actually. Okay, so in the drawing we have a quarter circle. AOB is a quarter circle. Inside the quarter circle we have a semicircle. And we also have line segment AM that is tangent to this semicircle at this point. Again, and we also know that side AO equals to 10 units, and our mission is to find out the length of line segment AM that is equal to X. To find out the value of X. So, first of all, because of the fact that this is a quarter circle, this angle AOB must be equal to 90 degrees. It is a right angle. In addition, AO and OB, they are both the radii of this quarter circle, therefore they are equal to each other. But AO equals to 10, therefore the other radius OB must be also equal to 10 units in its length. OB equals to 10. Okay, then we know that OB, that is the radius of the quarter circle, equals to 10 units in its length. But OB is not only the radius of the quarter circle, but it is also the diameter of the semicircle. So we know that the diameter of the semicircle OB is 10. Therefore the radius of the quarter circle must be equal to 10 over 2, that is 5. So we define the radius of this semicircle is P. This is the radius of the semicircle. So OP is the radius of the semicircle, that is equal to 5. PB is also the radius of this semicircle, that is equal to 5. Then we define the point of tendency of tangent AM with this semicircle as Q. Then we join points P and Q together by a straight line. Point P is the center of the semicircle, point Q is the point of the semicircle itself, therefore PQ is the radius of the semicircle, that is equal to 5 units. We have the radius PQ that is drawn to the point of tendency, that is to say it is drawn to point Q, that is the point of tendency of tangent AM with this semicircle. And whenever we have a radius that is drawn to the point of tendency, then tangent AM will be perpendicular to the radius QP. If AM is perpendicular to QP, it means that this angle equals to 90 degrees and this angle equals to 90 degrees according to rule number 1. And then we focused at point A. Point A is a common external point in relation to this semicircle. Why? Because point A is not located inside this semicircle, nor on the semicircle itself. It is located outside, therefore outside the semicircle, therefore it is an external point. It is a common external point. From the common external point, point A, we have two tangents to this semicircle, tangent AO and tangent AQ. And according to rule number 2, that states that the length of two tangents from a common point to a circle are equal, we get that AO equals to AQ. But AO is 10, therefore AQ must be also equal to 10 units in its length. Okay, then we extended AM, side AM and side OB by a straight line until they touch each other. We define the touching point of the extended AM and the extended OB as N. In this way, by doing this construction, we created here the big right triangle, triangle AON. In this big triangle AON, we define this angle, angle ANO as theta, and then we focus on this right triangle, triangle AON. In the right triangle AON, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees, that is the sum of the angles in any triangle. So the missing angle here must be equal to 90 degrees minus theta. Likewise, we focus then on the right triangle, triangle PQN. In the right green triangle PQN, this angle equals to theta. This angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta, according to the same rule that the sum of the angles in the triangle is equal to 180 degrees. So the missing angle here, angle QPN, the missing angle must be equal to 90 degrees minus theta. Then we prove that the green triangle is similar to the right big triangle, triangle AON. Why those two triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, angle theta is a common angle. It belongs to both triangles. So we can write down that angle theta equals to itself. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually prove that all the three angles in the right big triangle AON are correspondingly equal to all the three angles in the green small triangle, triangle QPN. Therefore actually proved that those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side AO with the big triangle over side QP in the small triangle equals to side AN in the big triangle over side PN in the small triangle, and it also equals to side ON in the big triangle over side QN in the small triangle. I repeat again, we derive that AO over QP equals to AN over PN equals to ON over QN. AO is 10, QP is 5, QP is 5. AN, what is the length of AN? In total, AN equals to AQ plus QN. But AQ is 10, so in total AN equals to 10 plus QN. Repeat again. AN equals to 10 plus QN over PN. What is the length of PN? From the drawing, it is very easy to see that PN equals to 5 plus BN. PN equals to 5 plus BN. Here PN equals to 5 plus BN, and it is equals to ON. What is the length of ON? ON in total equals to 5 plus 5 plus BN. That is to say, ON equals to 5 plus 5, that is 10 plus BN. So in total, ON equals to 10 plus BN. ON equals to 10 plus BN. Okay, and QN, we leave it as it is the missing sign. So in conclusion, we found out that 10 over 5 equals to 10 plus QN over 5 plus BN, and it is equals to 10 plus BN over QN. 10 over 5 is 2. So here, those two sides are equal to each other, those two expressions are equal to each other. So we created equation number 1 from those two sides that are equal to each other. That is to say, according to equation number 1, 2 equals to 10 plus Qn over 5 plus Bn. Then we created the equation number 2 from those two expressions that are also equal to each other. So according to equation number 2, 2 equals to 10 plus Bn over Qn. Repeat again. Those are the two equations that we created from the big equation number 1 and equation number 2. Then we multiply this equation number 2 by 5 plus Bn. So 2 times 5 plus Bn equals to 10 plus Qn. We open the brackets on this side of the equation number 1 and found out that 2 times 5 is 10, plus 2 times Bn is 2Bn, and it equals to 10 plus Qn. We have 10 on both sides of the equation, so 10 will get cancelled, and we left only with Qn, that equals to 2Bn. So according to equation number 1, Qn equals to 2 times Bn. This is according to equation number 1, while according to equation number 2, 2 equals to 10 plus Bn over Qn. Here we multiplied this equation number 2 by Qn, and we found out that 2 times Qn equals to 10 plus Bn. But Qn equals to 2 times Bn, so we can substitute Qn in this equation number 2 by 2 times Bn. We did it, and we got that 2 times Qn is 2 times, and Qn is 2 times Bn, equals to 10. 2 times 2Bn is 4Bn, that's equals to 10 plus Bn. Then we subtracted Bn from this equation number 2, and found out that 4Bn minus 3Bn is, we subtracted Bn from this equation number 2, and found out that 4Bn minus Bn is 3Bn, so 3Bn equals to 10. We divided this equation number 2 by 3, and finally found out that Bn equals to 10 over 3. Here, this line segment Bn equals to 10 over 3 units in its length. Then, according to equation number 1, Qn equals to 2 times Bn, and Bn equals to 10 over 3, so we put the value of Bn inside this equation number 1, so Qn equals to 2 times Bn, and Bn is 10 over 3, so it is 2 times 10 over 3, therefore Qn equals to 20 over 3. So in conclusion, found out that Qn equals to 20 over 3 units in its length. Okay, then we completed this quarter circle to a circle, and we extended side BO by a straight line until it touches the circle point C. We define the touching point of the extended side BO with this circle is C. So point O is the center of the circle, point C is the point of the circle itself, therefore C is the radius of this circle, that is equal to 10. The radius of the quarter circle and the radius of the circle are the same because we just extended the quarter circle to a circle. And the radius of the quarter circle is 10, therefore the radius of this circle itself must be also equal to 10, so CO equals to 10. Then we presented to you rule number 14, and we implemented rule number 14 in our drawing. According to rule number 14, rule number 14 is drawn in any circle. So in any circle, if you, from a common standpoint, you draw two chords to inside the circle, you will get that the following equation will be true. Here we have the common standpoint P. From the common standpoint P, we draw line segment PB. In this way, we created chord AB. Then from the same common standpoint P, we draw line segment PD. In this way, we created chord CD. So we draw here two chords inside this circle. Then in this drawing, the following equation is true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can actually implement rule number 14 in our drawing, because in our drawing we have the common standpoint point N. From the common standpoint point N, we have line segment NC that cuts the circle at points B and C. In this way, we have here chord BC. From the same common standpoint N, we have line segment NA that cuts the circle at points M and A. In this way, we have here chord AM. So we have from the common standpoint N, two chords that are created inside this circle, chord AM and chord CB. So all the requirements of rule number 14 are met, therefore we can implement here rule number 14. According to rule number 14, we get that NB times NC equals to NM times NA. Again, NB times NC equals to NM times NA. Okay, again, if we focus on the current standpoint point N, we can implement rule number 14 in our drawing. According to number 14, NB times NC equals to NM times NA. But before that, we actually calculated the length of line segment MN. We defined the length of QM as A, and we calculated the length of this line segment MN. From the drawing, it is very easy to see that MN equals to QN minus QM. Again, MN equals to QN minus QM. Repeat again. MN equals to QN minus QM. We just right now found out that Qn equals to 20 over 3 and Qm equals to A according to our definition. So in total, Mn equals to 20 over 3 minus A. Mn equals to 20 over 3 minus A. Here, Mn, this line segment Mn equals to 20 over 3 minus A. Then we return to rule number 14. According to rule number 14, NB times NC equals to NM times NA. If we focus on the common standpoint point N. NB is 10 over 3. And NC, what is the length? Here, NB is 10 over 3. NC equals to 10 plus 5 plus 5. That is 20 plus 10 over 3. So in total, NC equals to 20 plus 10 over 3. Repeat again, NC equals to 20 plus 10 over 3, and it is equals to NM. We just right now found out that NM equals to 20 over 3 minus A times NA. What is the length of NA? NA in total equals to AQ plus QN. That is to say, AN equals to AQ, that is 10, plus QN, that is 20 over 3. So in total, AN equals to 10 plus 20 over 3. Here, AN equals to 10 plus 20 over 3. Okay, so we actually found out that 10 over 3 times 20 plus 10 over 3. Here we multiplied 20 by 3 and then we divided by 3 in order to come from 10 over 3. So 20 times 3 is 60 and 60 plus 10 is 70. So in total in the numerator we have 70 divided by 3 and it is equals to, here we have 20 over 3 minus A. Here we multiplied minus A by 3 and then we divided by 3 in order to have a common factor with 20 over 3. So minus A times 3 is minus 3A. So in total in the numerator we have 20 minus 3A divided by 3. Here also we have 10 plus 20 over 3. We multiplied 10 by 3 and then we divided by 3 in order to have a common factor with 20 over 3. So 10 times 3 is 30 and 30 plus 20 is 50. So in total in the numerator here we have 50 divided by 3. So on both sides of the equation we have in the denominator 3 times 3, that is 9. Therefore we multiply this equation by 9 in order to cancel the denominator on both sides of the equation. So after we cancel the denominator on both sides of the equation, we left only with 10 times 70. That is equal to 20 minus 3A times 50. Here we divided this equation by 10. 10 over 10 is 1, so we left only with 70 in this side of the equation. And it is equal to 20 minus 3A times 50. 50 over 10 is 5. So total, in this side of the equation, we left only with 20 minus 3A times 5. Here we open the brackets on this side of the equation and finally found out that 70 equals to 20 times 5 is 100. Minus 3A times 5 is minus 15A. So 70 equals to 100 minus 15A. Here we added to this, we subtracted from this equation 70 and found out 70 minus 70 is 0. So 0 equals to 100 minus 70 is 30 minus 15A. Here we added to this equation 15A and found out that 15A equals to 30. We divided this equation by 2 and finally found out that A equals to 30 over 2, that is A equals to 30 over 15, that is 2. So A equals to 2. Here, this line segment QM, that is A, equals to 2 units in its length. Our mission is to find out the length of this line segment AM, that is equal to X. Again, we have to find out the length of line segment x that is equal to AM. And from the norm it is very easy to see that AM equals to AQ plus QM. Again, AM equals to AQ plus QM. AQ is 10 and QM is A. So in total, x equals to AM equals to 10 plus A. So x equals to AM equals to 10 plus A, and A is 2. So AM equals to 10 plus 2, that is 12. So in conclusion, found out that x that is equal to AM equals to 12 units in its length. This 9797 AM that is equal to x, it is equal to 12 units in its length. Okay, thank you very much.